Okay, so I need to get the numbers here. What do we have? We have time in hours. Then we have here activity, but I'm actually just going to put the activity here to make it a little bit easier for me to graph in the Office program. And here is log activity. Okay, so the time is 0, 4, 8, 12, 16, 20 and 24, and the activities are 90, 74.3, 58.5, 49.1, 38.4, 31.9 and finally 25.1. So this first question was so easy. All you need to do is get the logs of all of these numbers, yeah? So what was your first number? Did you get 4.49? Yep. And so on and so on and so on and so on and so on. So 2 marks. Now the next part is a tiny little proof, like really basic proof here. They want you to show that result. So you start off with A equals A0 E minus lambda T. Then what do you do? Log, yeah. So log A equals log A0 E minus lambda T. So log A equals log A0 plus log E minus lambda T. What happens to the log and the E here? They cancel. So you get log A equals log A0 minus lambda T. Or in other words, you get log A equals minus lambda T plus log A0. And you can see then that if this is the Y and this is the X, then this here is like the C, and then this here is like the slope. Okay, next we go back here and we want to make the graph. So I know you have to use graph paper, so try your best to do it as neat as you can in the exam, but this is what you should get when you draw it. So this is B4, and here is time in hours, and on the y-axis is log activity, and the units are logs mega E. And we should put in our line here. Now, what's nice for me is Excel can make the equation for me. So I can see, and I think you got this yesterday, Louise, the slope is minus 0.053. What did you get actually? Yes. Exactly the same. Minus 0.0532. Yeah, close enough. Good. Yeah, excellent. Okay. And you picked 2 points on the line. You use this formula. Yes. So, do you need me to do that, Abraham? It's okay. Are you sure? So I'll just write down the answer here that the slope equals minus 0. What did I say? 503 or 530? 0.053. Oh, that's actually, this is already part 4. So that means the lambda is equal to 0.053 per hour. Okay. And finally, the half-life, the formula is, oh my goodness, what is it? It's log 2 over lambda, isn't it? So that would be log 2 divided by 0.053. So that is 13.1 hours, or if you want it in seconds, 47,082 seconds, if you want it in seconds. Okay, B part now. I can do the B part? Yep. So in the B part here, you're told that the patient drinks this. You're also told that the A0 is 11.2 megabecquerels. The patient drinks this. Oh, sorry. You know what I'm also going to do? I'm going to change this into seconds as well, if I need it. So this is 1.47 times 10 to the minus 5 per second. Okay. The patient drinks this and 50% of it is in the patient's body. And the question is, what's the activity after 10 hours? So we just need to use this formula. A equals A0 E minus lambda t. So that is 11.2 times 10 to the 6 E minus lambda, and the t is 10 hours, or if you want 36,000 seconds, if we want to use seconds, which I like. Now, as Hu pointed out yesterday, in fact, if you stick with hours in this calculation, you get the same answer. It's a pity he's not here right now. He can tell us the answer he got. So this would be, I think he said this, no, this doesn't look right. This looks way too big. Let me double check my calculation. 11.2 times 10 power 6 times e power minus 1.47 times 10 power minus 5 times 36000. Yeah, so here I got 6.6 megabecquerels. But that's not quite the answer because the patient only drank half of it, so there's only half in the patient's body, so we just simply divide this by 2. So in fact the answer is really 3.3 megabecquerels. So this is the activity if the patient only drinks half of it. Okay, can I go down? So in part 2, how long until the activity is only 2? Now this question I think is made a bit more complicated because although the patient drinks all of it, but I've been saying he drinks half of it, only half of it makes it to the part we care about. So it's likely he only drinks half of it. Anyways, if the activity is 2 for half of it, if we had the full amount, what should the activity be before? Yeah, I'm being confusing here, sorry. So what's happening here is the patient drinks half of it, and after 10 hours the activity is 3.3. What should the activity be? It should be 6.6, but there's only half of it there. So I'm saying if the question says when is the activity 2 hours, you can think about it like this. You can think of it as when is the activity 4 hours if we use the full amount, or when is the activity 2 hours when we use half the amount. But I prefer to use the full amount because that, you see that 11.2 that they give us? That's for the full amount. In the question at the start, you see it says, a patient is given a drink and the initial activity is 11.2. So that's for the whole drink. But it says 50% enters the patient's thyroid after 10 hours. So maybe half of it, came out when he went to the toilet. Or maybe half of it he didn't drink. So I'm just saying here for the last one, I think we should make this a 4 because this 2 is 2 that's in the patient.
You could either make it a 4 or half.
True, yeah, we could either make it a 4 or we could have 11.2. I feel like most students in my class in September just make this half. I don't know, but I'm going to make this 4. Okay? So let's have a look at that. So we have 4 equals 11.2 E minus lambda T. You know how to solve this from math class. 4 divided by 11.2 log the answer divided by 1.47 times 10 to the power of minus 5. So you end up getting T is 70,000 seconds, roughly. Or if you want, that's roughly 19.5 hours. You definitely wanted this answer to be more than 10 hours because it took 10 hours to get it from 11 down to 6. So it should take longer to go from 6 to 4 then as well. So this one looks okay. Yeah. I don't like what they did about the 50% business in this question because I feel that made it more complicated. That they said the patient, only 50% is in the patient. Because they said there, you see there, if 50% has entered, so maybe the patient only drank 50%, or some other reason, only half of it is in the patient. So as you said, Abraham, maybe you can divide this number by 2, or you could multiply this number later by 2. But these are the problems you might have in the exam. So just be careful. As you see, I've already made 2 mistakes because I didn't read the question carefully enough. Yeah? And I'm a native speaker. But maybe because I'm a native speaker, I don't read it carefully. Maybe you read it more carefully because you're not a native speaker. Maybe. Okay, what else did we try from section B?